In the vast expanse of human innovation, a singular technological advancement has emerged to challenge our fundamental understanding of consciousness and morality. Today, we begin our investigation. Could the sophisticated algorithms we designed to serve humanity ultimately become the architects of our own systemic obsolescence? This serious inquiry marks the beginning of our deep academic investigation. Welcome to our comprehensive exploration of the 95th most significant occurrence in global history, the profound international debate regarding artificial intelligence ethics and its future impact on society. The conceptual roots of synthetic intelligence trace back to the intricate mechanical automata and philosophical inquiries of the Enlightenment's most brilliant mathematical minds. Early philosophers believed that human reasoning could eventually be automated if only the fundamental laws of logic could be expressed through a sufficiently precise and formal symbolic language. The development of basic calculating machines proved that mathematical operations were not exclusive to biological minds, suggesting that mental labor could potentially be offloaded to mechanical systems. By the 19th century, the ambition to create a universal computer reached a peak with Babbage's analytical engine, which included features we now recognize as essential to modern computation. The modern era of artificial intelligence was formally introduced by Alan Turing, who famously asked if machines could think and proposed a test to measure their behavioral intelligence. The term artificial intelligence was formally adopted during the 1956 Dartmouth Summer Research Project, where a small group of researchers defined the initial goals of the field. During this workshop, pioneers like John McCarthy and Marvin Minsky predicted that the problem of creating intelligence would be significantly solved within a single generation of academic effort. The early success of simple neural networks provided the initial evidence that mechanical systems could learn from experience, sparking a decade of intense optimism and massive government investment. The first major approach to machine intelligence was symbolic AI, which attempted to replicate human reasoning through a massive collection of explicit rules and logical if-then statements. Researchers developed specialized programming languages and expert systems that could manage complex medical diagnoses or play chess at a level comparable to human masters of the game. However, the initial optimism faded during the 1970s when the technical limitations of symbolic systems became apparent, leading to a significant reduction in research funding and public interest. The field was revitalized in the late 80s by the development of backpropagation algorithms, which allowed neural networks to learn much more complex representations from large volumes of data. The transition into the 21st century marked a definitive shift as the expansion of the internet created unprecedented volumes of digital information that served as fuel for intelligence. Statistical evidence indicates that the volume of digital data created worldwide reached 64 zettabytes by the year 2020, providing a massive data set for training modern neural network architectures. The concurrent development of high-performance graphics processing units allowed researchers to train models with billions of parameters, leading to the breakthrough era of modern deep learning systems. By 2015, convolutional neural networks surpassed human performance in image recognition tasks, marking the first major instance where machine capability exceeded biological limits in a specific domain. We must analyze the specific instance of the 2019 facial recognition controversy in London, where data revealed a 98% false positive rate among certain demographics. Legislative frameworks such as the European Union's Artificial Intelligence Act represent the first significant attempt to codify moral boundaries within technical development. Statistical evidence from the World Economic Forum suggests that 85 million jobs could be displaced by automation by 2025, creating an unprecedented social challenge. The rise of surveillance capitalism has further complicated this discourse, as personal data becomes a primary commodity in the digital economy and social structure. Modern diagnostic systems analyze millions of patient records to identify subtle patterns that human practitioners might overlook during clinical evaluations. The implementation of neural networks in radiology has significantly improved the detection rates for early-stage malignancies within diverse populations. Algorithmic transparency remains a critical requirement for ensuring that life-altering medical decisions are based on verifiable and unbiased computational models. Studies indicate that health data scarcity among specific ethnic groups can lead to inaccurate risk assessments in predictive wellness applications. Historical biases embedded within training datasets often manifest as systemic inequalities in the output of modern decision-making algorithms. Researchers are developing mathematical frameworks to measure and mitigate disparate impacts across various demographic categories in supervised learning. Rigorous auditing of training information is necessary to prevent the perpetuation of outdated social prejudices through automated recruitment software. Ensuring equitable access to the benefits of artificial intelligence requires a proactive approach to inclusive design and participatory development. The definition of fairness in machine learning is a complex philosophical challenge that involves balancing individual accuracy with group representation. Analyzing past failures in predictive policing reveals how skewed data can reinforce existing cycles of surveillance in marginalized urban neighborhoods. The deployment of mass facial recognition in public spaces raises profound concerns regarding the fundamental right to anonymity and privacy. Global activists are advocating for strict legislative bans on the use of biometric tracking technologies without explicit individual consent. The extraction of behavioral data for commercial profit has created a new economic paradigm known as surveillance capitalism. Protecting digital identity requires robust encryption methods and decentralized control over personal information in the interconnected world. Legal scholars suggest that the right to privacy must evolve to include protection against sophisticated algorithmic profiling and tracking. The development of autonomous vehicles has forced engineers to codify ethical priorities into software, effectively digitizing the classic trolley problem. Sophisticated decision trees allow self-driving systems to navigate complex urban environments by processing millions of data points every millisecond. Integrating autonomous transport into smart city infrastructure can significantly reduce carbon emissions and improve urban mobility for all citizens. The rise of generative AI has enabled the creation of hyper-realistic voice clones that can be used to spread sophisticated digital misinformation. Facial mapping technology utilizes thousands of unique biometric markers to verify identity, raising significant concerns regarding consent and surveillance. Maintaining digital truth in an age of synthetic media requires the development of advanced detection tools and a new standard for journalistic integrity. Algorithmic trading accounts for over 70% of the total volume in modern financial markets, operating at speeds beyond human comprehension. Automated financial systems are increasingly responsible for managing global wealth, necessitating a rigorous ethical framework for fiscal decision-making. Predictive analytics in finance can enhance market stability, yet they also pose systemic risks if algorithms behave in unexpected or correlated ways. The environmental cost of large-scale AI development is a growing concern, as massive data centers require significant amounts of energy for cooling. Statistical evidence shows that the energy consumption of large language models is growing exponentially, prompting a search for sustainable computing solutions. Designing energy-efficient architectures and utilizing renewable energy sources are essential steps toward creating a more sustainable artificial intelligence ecosystem. Reducing the carbon footprint of digital infrastructure is a critical responsibility for the architects of the next generation of computing technology. Generative AI is transforming the creative industries, raising complex questions regarding intellectual property and the value of human authorship. Legal scholars are debating whether AI-generated works can be protected by copyright law and how to fairly compensate human creators for their data. The emergence of AI art challenges our traditional definitions of creativity and invites us to reconsider the relationship between man and machine. International organizations like the United Nations are working to establish global standards for the ethical development and use of artificial intelligence. Global governance requires a collaborative approach between nations to ensure that AI technologies are used to benefit all of humanity fairly. International summits provide a critical forum for discussing the legislative frameworks needed to protect human rights in the age of automation. Establishing a unified global perspective on AI ethics is essential for preventing a digital divide and promoting international peace and security. The alignment problem remains the most significant technical challenge as we attempt to ensure that superintelligent systems act in accordance with human values. The future of human-AI symbiosis may involve direct neural interfaces that allow for seamless communication between biological and mechanical intelligence. Ubiquitous wearable technology will integrate artificial intelligence into our daily lives, enhancing our cognitive abilities and social interactions. In an optimistic vision of the future, artificial intelligence serves as a powerful partner in creating a sustainable and equitable world for all citizens. Public resistance to pervasive surveillance has led to a growing movement demanding the right to digital privacy and the regulation of biometric tracking. Activists argue that without strict oversight, automated systems could facilitate unprecedented levels of government control and social manipulation. In the realm of education, artificial intelligence provides personalized learning pathways that adapt to the unique cognitive needs of each individual student. The integration of virtual tutors can bridge the educational divide, providing high-quality instruction to learners in remote or underserved communities worldwide. However, the massive computational resources required for global edtech platforms necessitate a commitment to energy-efficient infrastructure and sustainable design. The emergence of lethal autonomous weapon systems has sparked an intense international debate regarding the morality of delegating lethal force to machines. Military strategists are increasingly utilizing AI-driven simulations to predict conflict outcomes and optimize the deployment of robotic defense systems. Ensuring meaningful human control over autonomous military hardware is a critical requirement for maintaining ethical accountability in modern warfare. Social media algorithms often create information silos, where users are primarily exposed to content that reinforces their existing beliefs and prejudices. The psychological impact of algorithmic engagement is a major concern, as data shows a direct correlation between social media usage and rising anxiety levels. Addressing algorithmic radicalization requires a fundamental redesign of digital platforms to prioritize factual accuracy and social cohesion over raw engagement metrics. In the field of biology, machine learning has achieved a breakthrough in protein folding, accelerating the development of new treatments for complex diseases. Automated laboratories allow researchers to conduct thousands of experiments simultaneously, significantly reducing the time required for scientific discovery. The synergy between human creativity and mechanical precision is defining a new era of innovation that promises to solve some of our most persistent scientific challenges. Precision agriculture utilizes autonomous machinery to optimize soil health and maximize crop yields through real-time data analysis. Overhead drone surveillance allows farmers to identify specific areas of stress within vast agricultural landscapes with millimeter precision. Advanced sensors provide a high-resolution map of soil nutrients, enabling the targeted application of water and fertilizers to ensure food security. The transition to smart farming is essential for reducing the environmental impact of industrial agriculture while feeding a growing global population. Autonomous rovers on Mars represent the pinnacle of machine intelligence, making real-time decisions in environments millions of miles from human intervention. The successful flight of robotic helicopters on other planets proves the viability of autonomous aerial exploration in thin extraterrestrial atmospheres. Future asteroid mining missions will rely on AI to identify mineral-rich targets and coordinate complex extraction operations in deep space. Deep space telescopes utilize sophisticated algorithms to process petabytes of celestial data, searching for signatures of life among the stars. Mapping the cosmic web requires the integration of neural networks that can simulate the evolution of the universe over billions of years. Supercomputers provide detailed models of ocean currents, helping scientists predict the long-term impact of rising temperatures on marine ecosystems. AI-driven power grids optimize the distribution of renewable energy, balancing supply and demand across vast international networks in real time. Satellite imagery coupled with machine learning allows for the precise monitoring of reforestation efforts and the detection of illegal logging. Robotic manufacturing facilities can produce life-saving vaccines at an unprecedented scale, responding rapidly to global public health emergencies. Predicting the complex structures of viral proteins allows researchers to design targeted therapies and accelerate the development of new medicines. Algorithmic spread simulations provide critical data for governments to implement effective public health interventions and protect vulnerable populations. As automation reshapes the global labor market, society must reconsider the traditional relationship between work, income, and human identity. Digital payment systems provide a transparent and efficient mechanism for distributing universal basic income to citizens in an increasingly automated economy. Strengthening social safety nets and promoting community engagement are essential for ensuring that the benefits of AI are shared by all members of society. The economic restructuring brought about by machine intelligence presents an opportunity to build a more equitable and inclusive global financial system. Digitizing ancient manuscripts ensures that the linguistic and cultural heritage of humanity is preserved for the benefit of future generations. AI-powered language models can translate rare and endangered languages, facilitating communication and understanding between diverse cultural groups. Real-time translation devices break down linguistic barriers, allowing for the seamless exchange of ideas and oral histories across the globe. Preserving indigenous languages is a critical component of maintaining the cultural diversity and intellectual richness of our shared human history. Empowering indigenous communities with digital tools allows for the revitalization of traditional knowledge systems within a modern technological context. We have meticulously dissected the historical milestones and moral complexities that constitute this 95th most influential event in our modern historical record and scientific evolution. Our extensive investigation proves that the ethics of intelligence are fundamentally about the preservation of human dignity and individual autonomy in an increasingly automated world. Please subscribe and like this video to support our historical research series. 구독과 좋아요를 눌러주세요. 감사합니다.